Hola, mi clase. We are doing 1.7 absolute value equations and inequalities. So I can solve absolute value equations and inequalities. So an absolute value is, remember, the distance something is from 0 on a number line. So if we had the absolute value of 2, we would say that's 2 because it's 2 away from 0 on a number line. All right, if we look at a number line, here's 0, here's 2, it's 2 away. But if we took the absolute value of -2, we actually would say it's 2 as well because it's a distance, and we never say a distance is negative. So the absolute value of 2 is 2, but so is the absolute value of -2. And then compound inequalities is where two inequalities are going to be joined, and it's an and or situation. So they either, we've done this before, right, when they face each other or when they face away from each other. It's just now we're going to have absolute values with these instead of equations. So we have absolute values. All right, so we're going to solve this for x. We have 7 equals the absolute value of x plus 2. So we solve these just like we would equations, except now absolute value is going to affect how we do this. So we're going to first go -2 from both sides. So the goal is to get the absolute value by itself before we can do something to check the two answers. So we'll go 7 minus 2 is 5. So I'm going to get 5 equals the absolute value of x. So what we basically do is we set up two problems, and these two problems is the positive version. Oh man.
Bo Pascal, please come to the office. Your sister is waiting. Bo Pascal, please come to the office.
Well, that sucks. So we want to find the two versions of this, right? So we have the positive, so we would say, absolute value of 5 is 5, but we also have that the absolute value of -5 is 5. So it's taking the positive and the negative. And so we actually would say that we have two solutions. We have x equals 5, and we have x equals -5. So actually both of these work to solve this equation. So if I did a quick check, if I did 5, the absolute value of 5 is 5. And then we go 5 plus 2, well, that's in fact 7. Well, if I do the absolute value of -5, right, plug it in right here, I get 5, and 5 plus 2 is 7. So you'll see that in absolute value equations and inequalities, we actually end up sometimes with two answers because of the fact that we end up with, we have two positive and negative versions of this, okay? Okay, so the second one, remember the whole goal is to get that absolute value by itself. So we have this absolute value already by itself. I don't have to do anything. So this is where we now have to split it into two equations because I have to go find those two answers. So just like here, I have a positive and a negative version, right? I have a positive and a negative version. I need to basically have a positive and negative version of this. So what we're going to do is two equations. I'm going to go 2x minus 3 equals the positive version, 1. And then I'm going to find the opposite and negative version. So I'm going to go 2x minus 3 when that equals -1. Okay, so we have to find those two answers. So notice I leave the absolute value part the same, but I take a positive version and a negative version of the solution because the absolute value can be positive or negative, right? So we're going to go plus 3. 2x equals 4, I'll divide by 4. Nope, I don't want to divide by 4. 2. I need to divide by 2. There we go. And we will say the first answer is x equals 2. I'll do the same thing to this equation. I'll get 2x equals 2 this time. I'll still divide by 2. And now we'll say x is equal to 1. So these are our two answers for this absolute value function. Okay, so if I plug in 2, I'm going to get 1, and if I plug in 1, I'm going to get 1. We can test it. 2 times 2 is 4. 4 minus 3, absolute value of that is in fact 1. If I plug in 1, I get 2 times 1 is 2. 2 minus 3 is -1, but the absolute value of -1 is still 1. So that is why it works. Okay, maybe, no, I'll do this one. Maybe the next one I'll have you try before you push play. So I'll do this one. So again, the whole goal is to get the absolute value by itself. Right now it is not. So I'm gonna first subtract 8. Remember, these are inverse operations, so I need to do inverse order of operations. So I'm gonna add, subtract first. 8 subtract, 5 subtract 8 is -3, right? Now I'm gonna divide by 3 to get this 3 outside of here. And that is gonna get me the absolute value of x plus 6 equals -1. Now this does not actually have two versions. We're gonna actually say this is no solution. The reason this is no solution is because absolute value can never be a negative. It's a distance and we do not talk about it as negative ever. So if you ever go to solve, and you get the absolute value of something equals negative, it will always be no solution due to the fact that absolute values cannot be cannot be a negative. It just doesn't work. Okay, so this is no solution. All right, so what I would have you guys do is maybe pause here and try number 4 and see how you do, and then push play and we will see how you do number 4. Okay, so what we should have done is set up two equations. 3x minus 6 equals the positive version, 12. And then we need to do 3x minus 6 equals the negative version, -12. So I'm going to add 6 to both sides. 3x equals 18, right? Divide by 3, and I get x equals 2, right? Nope, 6. I don't know how to divide. 6. I don't know where I got that from. Add 6 to this one. We get 3x equals -6. Divide by 3, and we get x equals -2. And there would be your two solutions. Now, it's okay to have x be a negative because it's inside the absolute value. It's not the equal to, like problem number 3. Okay, so it's okay to have x be negative because see how you can see it's in the absolute value. So at some point it'll become positive. It's only when your absolute value, like in number 3, equals a negative that it doesn't work. Okay, so this one, I'm just going to make it very clear. This one's no solution. Okay, so that's absolute value inequalities. So we're going to practice absolute value. Those are equations. We're going to do absolute value inequalities now. So the first couple I'm doing are just like very simple versions so you can understand how to graph them because it's an and or situation. So just like the last one, we need to separate these, right? Have my two versions. So we would have our x can be either 3, right? Less than 3, or it can be -3, be less than 3 because we need our 2, right? So those are our x's. So if we go to graph this, right, I'd have -3 here, -2, -1, 0. Oh, I just realized something. Hold on. I need my two opposite versions. I apologize. So when we do this, we're going to have our two opposite versions because we need to flip those signs, right? So when we have an inequality, it has to have an one or the other. So we're going to always have those opposites happen. So I'm going to have 3 less than 3. I'm going to have -3 greater than 3, right? I want it to be greater than. Am I explaining this right? I don't think I'm explaining this right. I apologize. I'm going to try this really hard. Okay, two versions. X less than 3. Opposite version. X greater than -3. That's what I'm trying to explain. Okay, one more time. So this is x less than 3 because it's my positive version. And then we have x greater than -3 because it's my negative version, right? Think of like dividing by a -1. I want the opposite version. I want the negative version. So we need to make this 3 negative, but we also, when I divide by a negative, right, it makes my inequalities flip. There we go. I got it. So the first one gets left alone. The other one gets made its opposite. So that's where it gets -3, but we also have to flip the sign to its opposite. So it's always the positive version, and then the opposite of that, which would be the negative version. So then we would graph it. I got this. -3, some of you are not having faith in me right now. -2, -1, 0, 1, 2, 3. So open circle, because they're both not equal to. I need x to be less than, and then I need my other one to be greater than. So that's going to be this compound situation because of the flipping of that inequality. I super apologize. So I'll do this one right? So we leave this one, x greater than 3, and then we do the opposite version. So we go x, flip my sign, -3. There we go. See, I can do this. So graph it. We're going to go -3, -2, -1, 0, 1, 2, 3. These are also open. But if you notice, this one says x is greater than 3. So actually my arrow is going to go that way. And this one says x is less than 3. So my arrow is going to go that way. So this is one of those compound inequalities up here. Sorry, I apologize. Number 1 is and this one is where we would call it an or, right? And is where they fill towards each other, and or is when they separate and have opposite answers of each other. Okay, and we did this when we solved inequalities. The only thing is now we're going to introduce absolute values. Okay, so here's an absolute value that we will actually solve. We will do together. Okay, so I'll take my original version, greater than or equal to 9. There's 1. And then we always take the other version, right? So 3x minus 6. Flip this sign, make it its opposite, right? So we have to take the positive version and the negative version. So now I'll solve them just like we normally do. Add 6. 3x greater than or equal to, 15? Divide by 3. We are going to get x greater than or equal to 5. Okay? Then we'll solve this one. Add 6. We get 3x less than or equal to -3. Divide by 3. We get x less than or equal to 1. So graph it. So these are my answers. There's 1. There's the other. So if I go to graph this, I'll put -1 here. 0, 1, 2, 3, 4, 5. These are both going to be closed because they're equal to. And then I'm going to plug in, and I need x greater than 5. So if this is 6, that's greater than, right? So I'm going to go this way. And then I need x less than -1. So that would be towards -2. And then that becomes, so this causes this to become an or situation because you can see they split from each other. Okay, so when solving an inequality, you take the original version, right? Always first. And then for the second answer, you flip the inequality and make the number negative. It's very similar to equations, except because when we take the opposite, there's no inequality. I didn't worry about the flipping part. Okay, and then sometimes we'll have an and, like in number 1, and sometimes we'll end up with an or, like number 3. Okay, so absolute value equations. To solve an absolute value equation, isolate the absolute value expression. We talked about that. Then write and solve two equations, right? The positive and negative version, and then solve. No graphing necessary. Absolute value inequalities. So if an inequality uses a less than or equal to, these symbols point to the variable in the solution uses and. If the inequality uses a greater than or equal to, and these symbols point to the variable in the solution uses an or. So that also might help when you're solving these, is that if it starts as a less than or equal to, it will end up being an and. And if it starts with a greater than or equal to, it ends up as an or. So that might help when you go to check your solutions, right? When you graph it, like, did you get an and or an or situation? You do need to graph those though, okay? So don't forget. So number 1 is an absolute value equation. Number 2, independent practice, is a absolute value inequality. Okay, until next time.